Santoor, or hammer dulcimer, is an amazing musical instrument with melodious sounds. I bought Santoor 2 years ago to start learning, but initially I did not realize how big time and effort it takes to tune all 93 strings of Santoor. As an electrical engineer, I wanted to build a machine to automatically tune all strings so I can spend more of my time on actually playing and practicing the instrument instead of tuning it. Even though there are few products available in the market for tuning guitar automatically, there is none for Santoor. Plus, the amount of complexity involved in Santoor tuning is 100 times more due to just sheer number of strings in Santoor versus guitar, as well as the torque required to tighten the strings is at least 10 times more in Santoor versus in guitar. Santoor can be tuned in chromatic scale or in different scale for playing classical music. With my auto-tuning machine, it's very easy to change tuning to either of them or even tell tuner to tune only strings needed for specific raga or a song. Here is the complete setup. On the right hand side is all the electronics needed for Autotuner, which includes Raspberry Pi, motor drivers, I2C expanders, etc. In the middle is the tuning machine hardware, which includes stepper motors, DC motors, as well as aluminum V-slot on which the whole assembly moves. Here is the actual demonstration of how tuning works. The tuner is at some random position right now, so it will first try to calibrate itself. On the left hand window, you can see target for tuning the string, which is a D sharp string. On the right hand side bottom window, you see close-up of DC motor. Since a DC motor moves only for a few tenths of milliseconds or a few hundreds of milliseconds, um, it would be hard to notice it in the big window. I have written an Android app to detect the pitch of the note that is currently being plucked by the auto-tuner instrument. Android app detects the pitch and sends that over to the Autotuner program. There is actually a web server running in Raspberry Pi, and that Raspberry Pi web server communicates that information to the Autotuner program running on the same machine. In the left hand window, you can see that the pitch that is detected is lower than D sharp. So DC motor is tightening the string. To avoid any spurious noise from other places except from the tuning strings, I make sure that two consecutive pitches picked up by the Android app are close by. So that's why sometimes you can see even though the servo motor is plucking the string couple of times, only action is taking only when there is a double confirmation that this is indeed not a spurious noise. Success. That string is tuned to D sharp and it's moving on to now next string, and you can see the target is now F4. In case of this string, you can see that string is currently over tightened and it needs to be loosened to bring the pitch down. And that's exactly what the tuner is currently doing. Since the string can give out different notes when plucked up or down, and there can be variation because of how the servo motor is mounted and it's plucking the string, I am just taking the measurement only when it's plucked in the upward direction. And that could be the reason why you may be wondering why the motor is plucking the string so many times, but the DC motor is taking action only very few times. Sometimes detecting the pitch can be a complex problem, since sound is made up of complex overlap of different frequencies. There is generally a bass frequency and harmonics of that bass frequency in the higher octaves. The Android program that is using some smart algorithm to detect the pitch can take time to understand exactly what is the pitch of the incoming sound. Great. This string is now also tuned to its target of F4. Moving on to the next string, and the target for that is G4 as it shows here, and it's already tuned there, so it has nothing to do. It just moves on to the another string for tuning that one. Thank you for watching my video. If you are interested in knowing more details related to this project, I have included the link in the video.